And I'm back with an example problem for you guys to work on. Please copy this down in your notebook now. The teacher can pause this video while you do so. Alright, so we have a sled that's being pulled across the barn floor by a force of 320 newtons. It doesn't say anything about being pulled at an angle, so I'm assuming that it is parallel to the floor. No need to use sine and cosine. Now the coefficient of sliding friction between the sled and the floor is 0.45. And the mass of the sled is 65. Great. So they want to know a couple things. They want to know the sled weight, they want to know the force of friction, they want to know the net force, and they want to know the acceleration. Well, let's start out with the first one, part A, and we will draw our free body diagram first. Now, I'm going to keep it simple. Alright, so we have a barn floor and we have a sled. Now, I'm not going to get fancy, but my sled looks like that. Okay. Again, we know, let's put in what we know. We know that the sled is 65 kilograms. So I'm going to write in 65 kg in the middle. Right. I know it's being pulled by a force. FP is equal to 320. Okay. A couple other forces that I know that exist are the weight, all right, FW, and that has to be countered by the normal force from the floor. All right. So I have three of these forces drawn. What does it say? The coefficient of friction between the sled and the floor is this. So because it says coefficient of sliding friction, I know there's friction. All right, so I'm going to add that one as well. And remember, friction opposes motion. So if we have a force being pulled, if it's being pulled to the right, then the sled is going to the right. So friction is going to act opposite. Okay? FR. And again, I don't know what that is yet. So part A says, what does the sled weigh? So now I have my free body diagram labeled with things that I know. I can start solving. Okay. Well, remember, weight, by definition, is FW. So we have FW equals weight, which is mass times gravity. Well, all I have to do there is substitute in the values. So FW is equal to 65 times gravity, the acceleration due to gravity, 9.8 meters per second squared. And I multiply those two together, and I get 637. And my label is newtons. Don't forget the units. All right, so now I can just come over here and I'll say my force weight is 637. All right, now we know that there are no other forces acting in the vertical. So let's go ahead and solve for Fn. So the sled is not going up and down. All right. So mathematically, let's solve for the normal force. Okay, first I'm going to start out, sum of all my forces in the y is equal to ma. Okay. We know, number one, that there's no acceleration up or down. The sled stays on the floor. And there's two forces, 1, 2, present vertically. So what are those? Well, I have Fn minus Fw equals mass times 0 acceleration. Right? So that goes away. That all goes to 0. And I have Fn minus Fw equals 0. So I just move Fw to the other side. Fn is equal to Fw. And what is Fw? It's 637. So Fn is 637 newtons as well. Okay. Let's move on. For part B, we are asked to find the force of friction acting on the sled. We can't figure that out right now with what we have in our diagram, in our free body diagram. We don't have enough information. But I am told that the coefficient of sliding friction between the sled and the floor is 0.45. All right. So what I can do, I'll just make a notation somewhere on my free body diagram that mu is equal to 0.45. All right. That's a little bit of information that doesn't really belong on any of these arrows, but just off to the side so I know, and I'm going to need that. Now, it's a good thing we just learned the equation for friction, which is friction is equal to mu k, kinetic in this instance here because it's sliding, times the normal force. And boy, it's a good thing we solved for that normal force. All right. You're going to solve for everything all the time anyway, just warning you there. So all we have to do now is plug in our values again. We have the mu, which is 0.45, so it's 0.45 times the normal force, which is 637, and we get a value of what? Now I'm going to round up to 87. Okay. So my friction force is 287 newtons. Okay. Did we solve the problem? Sure. What is the force of friction? All we had to do was use this equation. Now hopefully you're not just passively watching this and that you are actually plugging numbers in and solving along with me. All right? Don't just sit there with your mind half closed and your eyes all glazed over. Do this with me and you'll benefit ever so much from this. All right, let's continue on to part C. Part C asks, what is the net force acting on the sled? Well, we have all of our forces labeled. There are no other forces acting on this box, this sled. And we know that vertically, okay, let's see. I'm going to need red. Vertically, the sum of my forces is 0. Again, because they cancel out, opposite directions, it's balanced. Okay, that's when things even out, the up equals the down, that's called balanced. So the sum of my forces is 0. There's no acceleration. However, in the x direction, the horizontal direction, I have a discrepancy. Things are not even. My friction is less than the pushing force, the pulling force. So I'm going to start out with the sum of all the forces in the x is equal to mass times acceleration. Now, there's two ways I could solve for net force. I could either multiply these two and get a value, or I could just figure out this half of the equation, right, which would be Fp minus Fr. All right, that's what we're going to do here. They only want net force. Well, by taking the difference of these two, that's the net force. Just like the exercises we did the other day, where you have 3 or 4 arrows going in and out of a box, and you just find the net force. That's all we're doing here. So we take 320, subtract 287. Okay, so 320 minus 287, do it in your heads. We get 33. Okay? Therefore, the net force on this box, or on this sled, is 33 newtons. Question answered. Let's move on. All right, so now they're asking for the sled's acceleration, and I'm just going to go and continue what I was doing for part C. All right, so remember, it was like a second ago, and you should have it written down. But sum of all the forces in the horizontal is mass times acceleration, ma. And we said that we have a difference, well, let's see, Fp minus Fr is equal to ma. Well, we already know what this is. This is 33 newtons is equal to mass times acceleration. So we have 65 times a. And acceleration is what we're trying to find. So we just divide 33 by 65. And it comes out to be roughly what? You can yell it out, class. Even though I'm not here, I'll hear you in my heart. .51 meters per second. Okay. So, did we answer it? What's the sled's acceleration? Yes, 0.51 meters per second. All right, and that's how you solve these problems. You go around each area here, you figure out what the force is equal, and then you're able to determine the net force based on any difference. So good luck. You should be able to do the homework well. Enjoy your weekend. Sorry I couldn't be here with you guys to do this in person, but you will survive. Have a good weekend, guys.